All right, buckle up, everybody, because today you are taking a deep dive into the world of comets.
Ooh, comets.
Yeah, we're going to uncover some super cool, like, cocktail party-ready facts about comet chemistry. So you could be the life of the party.
So ready to be the resident comet expert?
Yes, exactly. You'll be able to, like, drop this knowledge.
Impress your friends?
Yes, exactly. Impress your friends. Um, so, like, what are comets actually made of? What are these, like, cosmic cocktails?
Okay, so the basic recipe for a comet, it's surprisingly simple. We're talking like frozen water, carbon dioxide, methane, and then you just sprinkle in a little bit of cosmic dust.
So, like, the water we drink, dry ice, and the stuff we use to, like, heat our homes.
Yeah.
That kind of mind-blowing.
It is, but here's the thing, right? These familiar ingredients, they don't exactly behave the same way out in the deep freeze of space.
Right, right.
So they become the building blocks of these incredible objects we call comets.
So it's not just the ingredients, it's like how they interact in this crazy environment.
Exactly.
Okay, cool. So let's zoom in on the heart of a comet, the nucleus.
Okay.
What's going on there?
So think of it as like a giant, dirty snowball.
Okay.
So this solid core of ice and dust, and usually it's just a few kilometers across.
A dirty snowball hurtling through space.
I know, right?
I love it. But isn't it weird that something so small can make, like, such a spectacular display in the sky? Like, how does that even happen?
Well, that brings us to the coma. So as a comet gets closer to the sun, things start to heat up, and that's where the magic of sublimation happens.
Sublimation. Okay, so the ice just, like, vanishes.
Not exactly vanishes, but it does skip a step. So instead of melting into a liquid, the ice transforms directly into gas.
Oh, wow.
And this creates this hazy cloud around the nucleus, and we call that the coma. And get this, it can grow to be absolutely enormous, sometimes like even bigger than a planet.
So it's like the comet just sprouts this giant, puffy atmosphere.
Yes.
I could see why that would be impressive.
Yeah, very impressive.
So, but how does that lead to the tail? Like, how does that happen?
So that's where the sun's power comes into play. So solar radiation and wind, they basically push on the gas and dust in the coma, creating those incredible tails that we see streaking across the sky.
It's almost like the sun is using the coma as a canvas
Yeah.
and painting these, like, cosmic masterpieces with light and wind.
I like that. I like that. And there's more. There's actually two types of tails, a dust tail and an ion tail.
Two tails. Okay, now I'm really interested.
Yeah, so the dust tail, that's usually whitish or yellowish, and it's created by sunlight pushing on these tiny dust particles, and it curves gently as the comet moves.
Okay.
The ion tail, on the other hand, that's bluish, and it's formed by the interaction of the coma gases with the solar wind. And get this, it always points directly away from the sun.
So no matter which way the comet's going, the ion tail is always pointing away from the sun.
Always.
Huh. That's fascinating. What a powerful force the solar wind must be.
Right.
Okay, and you said that these tails can stretch for millions of kilometers.
Millions.
That's mind-boggling.
It's huge. It's crazy. Making comets, like, if you think about it, like the largest objects in the solar system.
Wow.
When you consider their full extent.
That's incredible. Okay, so we've got this dirty snowball nucleus, a giant coma cloud, these insanely long tails, all thanks to the power of the sun. But I have to add, doesn't all this, like, sublimation, doesn't it take a toll on the comet itself?
Well, yeah, you're right. The process of sublimation that creates the coma and tails it is also slowly chipping away at the comet itself.
Oh, so each pass by the sun it's both, like, a spectacular show and a bit of a cosmic weight loss program for the comet.
Precisely. Each time a comet swings around the sun, it loses some of its mass.
Wow. So comets really are these dynamic, like, ever-changing objects.
Exactly. And it's amazing how much we've learned about these transformations thanks to, recent space missions.
Oh, yeah. Like the Rosetta mission, right?
Yeah, Rosetta.
And its little lander, Philae.
Yeah.
It was like landing on a comet's nucleus. It's like something straight out of a science fiction movie.
It's incredible.
It really is.
A truly remarkable achievement.
Yeah.
And the data they sent back, groundbreaking. It confirmed a lot of what we thought we knew about comets, but, there were also some surprises.
Ooh, surprises. Like what?
Well, one of the most intriguing findings was the detection of organic molecules on the comet's surface.
Wait, are you saying that comets might be carrying the ingredients for life itself?
It's a possibility that has scientists really excited. It raises some fascinating questions about, the role that comets might have played in bringing these crucial elements to Earth billions of years ago.
Wow. Talk about a cosmic delivery service. So it's not just about the show, it's about the potential secrets they hold about, like, the very origins of life.
Precisely.
That is incredible. So how do we actually study these icy wanderers? We can't exactly hop on a spaceship and take a closer look, right?
Not yet, but we have developed some incredible tools to study them from afar. So telescopes, both on the ground and in space, allow us to analyze the light reflected from comets. It's like taking their cosmic fingerprints.
So we're using light to decode their secrets.
Exactly, we are. And then, of course, there are those daring spacecraft missions that we mentioned earlier. Like Rosetta, we've sent probes to fly by comets, orbit them, and even, land on their surfaces.
Yeah, and those missions have just been game changers, providing like up-close images, detailed chemical analyses, even measurements of their internal structures. It's mind-blowing.
It is, and the technology just keeps evolving. We're constantly developing new instruments and sensors that will allow us to probe comets in even greater detail on future missions.
Okay, so before we wrap up, I want to make sure our listeners are armed with those 5 cocktail party-ready factoids about comet chemistry.
Great idea. Let's do it.
So number 1, comets are made up of frozen water, carbon dioxide, methane, and dust. They're like these cosmic cocktails with ingredients we see every day, just in a totally different form.
Right. Factoid number 2, at the heart of a comet is the nucleus. That solid core of ice and dust. Like a giant dirty snowball hurtling through space.
Number 3, when a comet approaches the sun, the ice undergoes sublimation. So it transforms directly from a solid to a gas, creating the coma, that hazy cloud surrounding the nucleus.
Factoid number 4. The interaction of that coma with sunlight and solar wind creates the iconic tails.
The tails, which could be either a dust tail or an ion tail,
Exactly.
stretching for millions of kilometers.
Millions.
And lastly, factoid number 5, sublimation is not only responsible for those stunning visual changes, but also for the comet's evolution over time. Each pass by the sun slowly chips away at its mass, like a cosmic sculptor shaping its destiny.
Beautiful. There you have it.
5 cometary conversation starters.
Guaranteed to make you the life of the party.
Exactly. But remember, there's so much more to comets than just these factoids.
So much more. They've captured our imaginations for centuries.
Right, like they've been seen as everything from like omens of doom to celestial messengers.
Right.
And they pop up in our myths, our art, our literature.
Everywhere.
It's amazing how these chunks of ice and dust can hold such a, profound place in our cultural history.
It really speaks to that deep human connection we have with the cosmos, that desire to understand our place in this vastness of space.
Absolutely. And speaking of understanding, let's talk a bit more about the science behind studying comets. It's a field that's come a long way in recent years.
Oh, absolutely. Technological advancements and those, incredible space missions, they've revolutionized our understanding of comets. We've gone from observing them through telescopes to actually landing probes on their surfaces.
Yeah, it's mind-blowing when you think about the ingenuity and precision it takes to, pull something like that off, landing on a comet.
It's incredible.
It's like science fiction becoming reality.
It really is. It's a testament to the human spirit of exploration, our drive to push the boundaries of what's possible and explore the unknown.
And the data we've gathered from these missions has just been remarkable, confirming some of our long-held theories, but also presenting some really unexpected twists.
Yeah, like that discovery of organic molecules on a comet's surface. I mean, that finding has really shaken things up in the scientific community.
Yeah. It's just incredible to think that these icy wanderers traveling through the vast emptiness of space might actually hold clues to the very origins of life itself.
It really highlights the interconnectedness of everything in the cosmos, from the smallest particles to the largest celestial structures. It's all part of this grand cosmic dance.
I love that. Okay, so imagine you're a chemist analyzing a sample of cometary ice. What would you expect to find?
Well, we would definitely see the usual suspects. Hydrogen and oxygen, which are, the components of water. We'd also find carbon, nitrogen, and traces of other elements like sulfur and phosphorus.
And those are all essential elements for life as we know it.
Exactly. It's a reminder that the basic ingredients for life are widespread throughout the universe.
So maybe we're not as unique as we once thought.
Maybe not.
It's kind of a humbling thought, and it opens up so many exciting possibilities for, future exploration. We've come a long way in understanding comets, but Clearly, there's still so much more to learn.
So much more.
And each new discovery raises new questions,
Exactly.
pushing us to, refine our theories and develop even more advanced methods of study.
Absolutely. It's an exciting time.
It really is. Well, it seems we've reached the end of our cosmic cocktail party. I hope you've enjoyed this deep dive into the fascinating world of comets.
Me too. And remember, the next time you gaze up at the night sky and see a faint streak of light, you're witnessing a time capsule from the dawn of our solar system, a celestial messenger carrying secrets we're only beginning to unravel.
That's beautiful. And as we continue our exploration of the universe, we can be certain that comets will continue to inspire awe and wonder, and perhaps even a few more cosmic cocktail-fueled conversations.
Cheers to that.
Cheers. Until next time, keep those minds curious and never stop exploring.
Never stop exploring. It's like each trip around the sun, the comet kind of slims down a little.
Like a cosmic spa day.
Exactly, exactly. And, it's amazing what we've learned about these transformations, all thanks to recent SPICS missions.
Oh, yeah? Like Rosetta and Philae.
Yes, Rosetta and Philae.
Landing on a comet's nucleus. That's like sci-fi stuff.
I know, right? It was really a remarkable achievement. And the data they sent back, groundbreaking. It confirmed a lot of what we thought about comets, but there were also some surprises.
Ooh, surprises. Like what?
Well, one of the most intriguing things they found were organic molecules on the comet's surface.
Wait, hold on. Are you saying comets could be carrying the building blocks of life?
It's a possibility that's got scientists buzzing. It raises so many questions about how those elements might have gotten to Earth, billions of years ago.
Wow, so comets, they're not just putting on a show. They might be, delivering the ingredients for life?
It's a wild thought, right?
That's incredible. So how do we even study these things? We can't exactly, just take a field trip to a comet, right?
Not yet, at least. But we've got some pretty incredible tools to study them from afar.
Okay.
Telescopes, both on the ground and in space. They let us analyze the light reflecting off the comets. It's like taking their cosmic fingerprints.
So we're like cosmic detectives using light to unlock their secrets.
Exactly. And then, of course, we've got those spacecraft missions. We send probes to fly by, orbit, and even land on them.
Yeah, those missions are game changers. They're giving us up-close images, detailed chemical analysis, even peeking inside their structures. It's crazy.
It really is. And the tech is always evolving. New instruments and sensors. It's all going to allow us to really delve into comets in even more detail, with future missions.
It's a great time to be a comet enthusiast. So before we wrap up, let's give our listeners those 5 cocktail party factoids about comets.
Okay, let's arm them with knowledge.
Number 1, comets are made up of frozen water, carbon dioxide, methane, and dust. It's like they're these cosmic cocktails, but with ingredients we see every day, just in a totally different form.
Factoid number 2. At the heart of every comet, there's a nucleus. It's that solid core of ice and dust. Basically a giant, dirty snowball, but zipping through space.
Number 3. When a comet gets close to the sun, that ice goes through sublimation, so it transforms directly from a solid to a gas, creating the coma, that hazy cloud around the nucleus.
Factoid number 4, that coma interacts with sunlight and solar wind, and that creates those iconic tails.
And remember, those tails can be dust tails or ion tails,
Right.
stretching millions of kilometers.
Millions.
And last but not least, factoid number 5, sublimation. It's not just responsible for the light show, it's also what causes the comet to evolve over time. Each pass by the sun, it chips away at its mass. It's like a cosmic sculptor.
That's a great way to put it.
Shaping its destiny.
Okay, so there you have it.
5 cometary conversation starters.
Guaranteed to impress.
Exactly. But there's so much more to comets than just these factoids.
They've captured our imaginations for centuries.
Yeah, they've been seen as harbingers of doom, celestial messengers.
It's true.
You see them pop up in our myths and legends, our art.
Everywhere.
It's amazing how, these chunks of ice and dust, they had this really profound place in our history.
It really shows that connection we have with the cosmos, that desire to understand our place in this vastness.
Speaking of understanding, how about we dig a little deeper into, the science behind studying comets? It's come a long way.
Oh, absolutely. Technology, those incredible missions, they've changed everything about how we understand comets. We've gone from watching them through telescopes to actually landing on them.
When you think about the ingenuity and precision it takes to pull that off, landing on a comet,
Mind-blowing.
that is science fiction becoming reality.
It really is. It speaks to our, the human spirit of exploration, that drive to push those boundaries, and explore the unknown.
And the data that we've gathered, it's amazing. Confirming some of our theories, but also throwing in some curveballs.
Like those organic molecules?
Yeah.
That's really got the scientific community thinking.
It's incredible to think that these icy wanderers in the vastness of space might hold clues to the origin of life itself.
It really highlights, how everything is connected in the cosmos. From the tiniest particles to the largest structures, it's all part of this grand cosmic dance.
So let me ask you this. Imagine you're a chemist and you're analyzing some cometary ice. What would you expect to find in there?
Well, we'd definitely see the usual suspects, so hydrogen and oxygen, the stuff that makes up water. We'd also find carbon, nitrogen, maybe traces of things like sulfur and phosphorus.
And those are all essential elements for life as we know it.
Exactly. It just goes to show that the basic ingredients for life, they're all over the universe.
So maybe we're not so unique after all.
Maybe not.
That's kind of a humbling thought. And it opens up so many exciting possibilities for future exploration. Like, we've come a long way in understanding comets, but clearly there's so much more to learn.
So much more.
And every new discovery just raises more questions.
It keeps us going.
It pushes us to, like, refine our theories, develop new methods of studying them.
Yeah. It's an exciting time.
It really is. Well, it looks like we've reached the end of our cosmic cocktail party. I hope you've enjoyed this deep dive into the world of comets.
Me too. And the next time you look up at the night sky and you see that streak of light, that's a time capsule from the beginning of our solar system. A celestial messenger with secrets we're only starting to understand.
That's a beautiful way to put it. And, as we keep exploring the universe, you can bet comets will continue to, like, inspire awe and wonder.
Absolutely.
And maybe, just maybe, even fuel a few more cosmic cocktail conversations.
Cheers to that.
Cheers. Until next time, keep those minds curious and never stop exploring.
Never stop exploring. Yeah, it's like every comet is a little time machine.
I like that. A little time machine hurtling through space. So we talked about, like, the cultural impact of comets, but let's circle back to the science for a bit. How has our understanding of comets evolved over time?
Well, it's really incredible to think about how far we've come. Like, just a few decades ago, comets were these mysterious objects. We knew so little about them. But with advancements in technology, those amazing space missions,
Yeah.
it's totally revolutionized our understanding of comets.
Like going from observing them through telescopes to actually landing on one. It's mind-blowing.
I know, right? It's really a testament to, like, human ingenuity, that drive to explore, to push the boundaries of what we know and the data we've gathered. It's been so valuable.
Yeah, confirming some long-held theories, but also throwing in some surprises along the way.
Like those organic molecules we talked about.
Right, the building blocks of life, potentially just hitching a ride on a comet.
Exactly. It makes you wonder, what else is out there? What other secrets are these comets holding?
It's a question that keeps scientists up at night, for sure. Okay, so imagine you're a chemist, right? And you've got a sample of cometary ice in front of you. What are you expecting to see when you analyze it?
Oh, that's a fun one. Well, we definitely see the usual suspects: hydrogen, oxygen, the components of water. But we'd also find carbon, nitrogen, and maybe even traces of things like sulfur and phosphorus.
And those are all, like, essential elements for life as we know it. It's pretty incredible to think that those building blocks are present in these, icy travelers.
It is. It really highlights that the ingredients for life, they might be more common in the universe than we initially thought.
It's a humbling thought, and it opens up so many possibilities for future exploration. We've come a long way in our understanding of comets, but there's still so much more to uncover, so much more to learn.
Absolutely. Every new discovery, it just leads to more questions. It keeps us curious. It keeps us exploring.
It really does. Well, it seems we've reached the end of our cosmic cocktail party. I hope you've all enjoyed this deep dive into the fascinating world of comets.
Me too. It's been a blast.
And remember, the next time you look up at the night sky and see a comet streaking across, remember, it's more than just a beautiful sight. It's a time capsule from the early solar system, a celestial messenger carrying secrets that we're only just beginning to unravel. So until next time, keep those minds curious and never stop exploring.